I just cut off on that last video just before I explained why that was so cool to have that completed form. But it's the standard form, so I'll put a little red star here by if I can get my red to come back. There we go. This is what's called the vertex form of a quadratic, and so h and k are the vertex. And h is the number that's being subtracted from x, and k is the number being added on the outside there. So for us, we have 3, and what's going to end up, since it's minus 6, it's funny, the h is going to be opposite, so you see a minus 3, but the x coordinate's actually 3, you see over here. And then it's on the outside, that minus 6 is the opposite of k, so it ends up being negative 6. That's a little hairy. You just have to remember you have minus h and plus k, and drink carefully, honey, use 2 hands. And so you get your 3, negative 6 is your vertex. And then I don't know if in the video I had on the intercepts that you're supposed to find the zeros. You don't have to do the vertex twice, it's just a typo on there, but I did it there for fun. But the y-intercept, remember from yesterday, is when we set x equal to 0. In any equation of your choice, you can put it in the most recent one that we were in the vertex form, or you can go back to the very beginning and put 0, and for each of the x's up there, that would mean 0 minus 0 plus 3, we'd get 3. So if we do that, that's where the y-intercept here is 3. And that's interesting stuff. We have a lot of points. We have a vertex of 3, negative 6, and a y-intercept of 3. If you wanted to go into this graph, you could actually go 3, negative 6, and if I count right, I hope I do. There's 3, negative 6, and you plot your points. And if I'm off, just make fun of me here. 1, 2, 3, 4, 5, 6, there it is. And then you have a y-intercept of 3 up here. Maybe I should clean up a little bit so you can see that. That's right here on that edge. And we know the parabola is going to kind of do one of these businesses here. One other piece of information that would help us sketch this is the x-intercepts, where we set y equal to 0. And if I set y equal to 0, as I've done over here, it's a little bit more complicated. A little solving. So here's y equals 0. Add 6 to both sides. So get this. And then you introduce a square root to both sides to get rid of the squared involved. So we go to that right now. So I'm square rooting both sides to get rid of the x minus 3 quantity squared. Graham, be careful, honey. No more messes. And if you introduce a square root, you always have to have, Kieran, you hold on the whistling, a plus or minus. So you always introduce a square root, you always have to put the plus or minus. And so if you square root to get rid of the squared, these essentially cancel each other. You get x minus 3 left, but you have to have a plus or minus square root of 6 because you introduced a square root, and it means we have 2 different values of x. Remember, these are x-intercepts. So we got 3, if I add 3 to both sides, down here, plus 3, I get x is 3 plus or minus the square root of 6. And that means you have 3 plus the square root of 6, about 5.5, and 3 minus the square root of 6, about 0.5, are x-intercepts. So it was a little bit more involved, and we'll do more of that solving business here, especially next week, talking about what do you do with square roots. Because if you think anything I'm mentioning and you see it once, we're going to see it again, because all these are kind of early ideas we haven't seen in a while. And then here's 5.5. Those are my x-intercepts. It kind of helped me complete my parabola. I had a vertex because I completed the square and I did the vertex form. So 3, negative 6. Got the y-intercept by setting x equal to 0, and then I got the x-intercept by setting y equal to 0 and doing some series algebra. And there's a sketch. So that's a pretty long process and something that definitely takes practice and a lot of questions. So get ready. Do one more. I'll have an opportunity here. Let's go down to number 11. This completing the square is a little more involved. But again, you group x's and y's. So you group your x's. So what I'm going to do is take f of x and put my negative 2x squared plus 8x in parentheses. I'm going to pull those together, minus 3. And then if you take, and this one is not ready to complete the square because this has to be, needs to be 1. Needs to be 1. Be 1 as a coefficient right there. So you have to factor it out. So this one's going to be f of x equals, if I take out that negative 2, then you get negative 2, and then the x squared after dividing out negative 2 from these. Remember, factoring is to divide out a common term, divide out negative 2. And what ends up being left is x squared, and that's a minus 4x. And then leave some room. Minus 3 carries on, but what we're going to do is complete the square because we have a coefficient of 1 now. So we group x's. There's a factor next to the x squared. Make sure you factor it out. You have to factor it from both, so this becomes minus 4x. Completing the square is when we take half the middle term, square it, and add it. So we're going to take negative 2, and we are going to square that negative 2, which is 4, and add it to that what was that quadratic inside the parentheses. That's physically completing the square. We just added something to this equation, and the way you have to undo, you just added not just negative 2 squared, and I wrote 4 on there. Oops, sorry about that. If you take negative 2 squared, that's 4. So think of it as 4, and that's fine. But we didn't just add 4, we actually added negative 2 times 4, because you have to account for that negative 2 out there. So we have to subtract out that negative 2 times 4 that we just put in there by completing the square. Okay, so you have to undo. Every time you complete the square, there's something that you have to compensate for or undo. And we're not just adding negative 2 squared, we're not just adding 4, we're actually adding negative 2 times negative 2 squared. Okay, so we have milk water taking place next to us. If you hadn't already noticed, I'm sure it's terribly distracting. Graham, hang on just a second, buddy. This is the next piece, that trinomial that you made, that really important piece. That's where the big bucks are. I'm going to highlight that for us. Look at it with me right here. That trinomial is now x minus 2 quantities squared. So that's what we're going for. Half the middle term squared and added means I can rewrite that trinomial in the middle. Everything else stayed the same. The negative 2 up front still there. The minus 3 minus this negative 2 times 4, that's actually negative 3 plus 8. So that ends up being 5. So we're going to put 5 on the end there, right? Does that seem right? Negative 3 plus 8 makes positive 5. Good. And then that's actually ends up being our vertex form of our parabola. So that's perfectly good. But let's go back and recount what we just did. Hey, Graham, good word, please. You group your x's and y's, so we did that. Didn't like that there was a 2 in front of that x squared, so we factored it out. Both terms, the 8x divided by negative 2 made this negative 4x. We completed the square, which is half the middle term squared and added. And notice that half middle term is part of how we complete the square. That minus 2 becomes part of our binomial squared. And when you added negative 2 squared, you can't just randomly add that. And it's not just adding 2 squared, it's actually adding negative 2 times that. You have to subtract that out. So here we are compensating for it, undoing, subtracting out what we did. And so in the end, that trinomial I highlighted in yellow can be rewritten as x minus that half the middle term squared. And then in the negative 3 and the negative 2 times 4 is like adding 8. So we made it 5. And if you look carefully in here, here's our h and k. H, the x coordinate of the vertex, is 2. And our k, the y coordinate, is actually 5. So we're going to go 2, 5 is our vertex. That's the start of where we're going to graph this thing. You go over 2, up 5. 1, 2, 3, 4, 5 is our vertex. And then the other things we can find are important. So negative, or this 2 negative, what was it? Yeah, 2, 5. You can find where I wrote it. Excellent. And the y-intercept is from x equals 0. And we just put 0 in for x. If we go to our original equation, put zeros in there. Hey, Graham, use good words, please. You get negative 3. 0 cancels those out, and you get negative 3. So y equals negative 3. Okay, so I'm going to put that on my graph as well. So if I go to negative 3, plot that point, boom, we're on our way. The zeros, as in the x-intercepts, are when y equals 0. And so you take any form of your equation, I'll choose the last one, just for solving purposes. But 0 equals negative 2 times x minus 5, quantity squared, plus 5. That's setting y equal to 0. And to get to x, you're going to subtract 5 from both sides. Okay, we do order of operations backwards. You want to get rid of this negative 2 by dividing both sides by negative 2. And that makes 5 halves, or 2.5 if you prefer, is equal to x minus 5 quantity squared. And then finally, we have to undo that squared with a square root, and you always put a plus or minus when you introduce a square root. So you're going to square root both sides. Hang in there on those. So you end up with plus or minus the square root of 5 halves is equal to x minus 5. We're almost there. Lastly, you get to add 5 to both sides. So you get x is 5 plus or minus the square root of 5 halves. And they're decimals. It's nothing that you want to go get too detailed about. But you could plug it into a calculator and get those x-intercepts. And I need to cut this video off here to tackle the next mess that happens. But you can imagine they're going to happen if I complete this little sketchy sketch. Those x-intercepts will intersect there. And definitely, you want to, at this point, just use your calculator to get both x plus the square root of 5 halves. And you want to do x minus the square root of 5 halves and get those values so you can just roughly sketch them onto your sketch. Pretty tricky, isn't it? It's a lot of work that goes into completing the square. That's something that we'll want to work on come Monday, and also something that on your own time you might say, hey, how do I factor or do completing the square to rewrite a parabola? You could Google something like that, or just rewatch this at home because I linked it to you guys at my Google Classroom. See you soon.